Okay, so chapter 4 is all about congruent triangles, and we're starting with basic ideas that we can build on to prove that triangles are congruent. Today we want to talk about some things that you already know and also some new ideas. First thing, you need to be able to classify triangles by their sides and by their angles. By their side, this is all review for you, making sure we're all on the same page. Equilateral triangles have 3 congruent sides. You can look for the markings to see that. Isosceles triangles, this is probably new for you, at least 2 congruent sides. So that means 2 congruent or 3 congruent sides can still be called isosceles. Scalene triangles have no congruent sides. Again, that's review. If you're classifying them by angles, if it's an acute triangle, it has 3 acute angles. If it's a right triangle, it has 1 right angle, of course. And an obtuse triangle has 1 obtuse angle. Again, this is review. You should be able to classify a triangle either way. Important terms. Vertex of a triangle is where the 2 sides meet. So the A, B, and C are all vertices of that triangle. A, B, and BC are adjacent sides. So if you look at where A, B, and BC are, here's A, B, and here's BC. They are next to each other, which is what adjacent means. AC is opposite angle B. So if here's angle B, the side that's opposite, you can kind of draw an angle to. So if you're looking for a side that's opposite angle B, you can draw that arrow, and AC would be the opposite side. This should also be reviewed for a right triangle. The hypotenuse is directly across from the 90 degrees. The legs are the 2 sides that make up the 90 degrees. That's only for a right triangle. This is important for a new idea today. So if you look at my actual triangle, the interior angles are probably pretty obvious, the inside. Exterior angles are the ones that are not associated with the inside angles. So if you look at my inside angle, here's my inside angle. This would be the vertical angle for that inside angle. The exterior angles are the other 2 that make that intersection. So if you think about a triangle, if I take any of those sides and extend it out, this would be your exterior angle. The inside angle, again, is what's associated with the inside angle. So make sure you see the difference between inside angles and outside angles. That's important. Some new theorems. This is one you've already heard. Sum of the measures of the interior angles of a triangle is 180. You know that. Now you know that there's a theorem associated with it. Corollary to that same triangle sum theorem, the acute angles of a right triangle are complementary. And that should make sense because if I have a right triangle and I know all 3 angles have to add up to 180, and I know that this one's already 90, then these 2 have to add to 90. That's what that theorem says. And a corollary is kind of like an add-on. That's what that means. Exterior angle theorem. This one's a big one that you'll apply quite a bit. Measure of an exterior angle is equal to the sum of the 2 non-consecutive interior angles. Non-consecutive means it's not next to it. So looking at my picture, this is my exterior angle, angle 1. This is equal to the sum of these 2 angles. This would be consecutive or adjacent. These 2 are non-consecutive. So this angle is equal to adding these 2 together. So that's going to be helpful in finding different angles of a triangle. So let's look at a couple of examples using these ideas. First example is pretty simple. We're classifying by its sides and its angles. First of all, looking at our example, 2x, 3x, and 4x. Well, I know that that's going to be scalene because I have different angles, which means I'm going to have 3 different sides. When I set this up, I know that when I add these 3 angles together, it has to add to 180. When I solve this, I combine like terms, divide by 9, I got x is 20. So when I plug that in, I can see that all of my angles are acute. So this would be 60, this one would be 80, and this one would be 40. So all 3 angles are smaller than 90, which means it's an acute triangle. So it's scalene by its sides, acute by its angles. Example 2, we're looking for the measurement of x and y. This one's a little bit more complicated. We're using systems of equations to solve this one. So what I did was the first thing I looked at was 7x plus 1 plus y plus 38 gives me 180. Now where that came from is concentrating on this triangle. You can see this angle is the 7x plus 1, this one's 38. Well, these are vertical, so I put y in here. That's where this came from. The next one what I did from here was simplify, so I added the 38 and the 1 and moved it over, so I simplified it into kind of a standard form. This equation came from this intersection here. So this angle, y and the 10x plus 9 are a linear pair, so I know they add to 180. That's where this equation came from. Simplified it so that it's in the same format as the first equation. My next step is I took this, and I'm going to solve it by using a system of equations. And by looking at this, I knew my y's have the same coefficient, and if I change it to negative, that means that that y is going to go away, which is what I want using elimination. So when I copied it down here, they were all positive, then I changed it to a negative. So I made 10x become negative, I made the y be negative, and I made the 171 be negative. When I added these two equations, 7x minus 10x gives me 3x, y minus y makes it go away, which is what I wanted. 141 minus 71 gives me negative 30. Now I have a one-step equation that I know how to solve. Divide both sides by negative 3 and I got x equals 10. So I'm halfway there. I still have to find what y is, so you plug it back into one of my original equations. I picked this one. So instead of 7x plus y equals 141, I plugged 10 in for x, so now I only have one variable. When I solved that, I got y equals 71, which is what we needed to do. The last example, so again, we're looking to find x. This is a direct example of exterior angle theorem. So here's my exterior angle. That exterior angle is equal to the sum of the two non-consecutive interior angles. This is a consecutive angle. These two are the non-consecutive interior angles. So this equals the sum of these two. That's where this equation came from. So 9x plus 2 plus 40 equals that outside angle. That's where this equation came from. Simplified the right, negative 2 plus 40 gives me 38. Moved my 9 over, so 20x minus 9x gives me 11x. Subtracted the 5 on this side, got 33. Divided both sides by 11 and got x equals 3. So there's a couple of examples for you to help you get started. Remember, you will have a quiz on these ideas next time, and I'll answer any questions that you have. Here's your homework. The first section is on 4.1, the stuff that I just explained. This is review of graphing inequalities. If you need help getting started, feel free to look at my answer key to get you started so you understand it, but you will need 6 graphs because you're graphing 6 inequalities.